Hello viewers, here's another example. We have to prove by induction that this equals to this. And to prove by induction, we have just 3 steps or 2 steps. So the step one now, to prove this, you put one here, put one here, compare the two results. Our proposition, when n equals to 1 raised to the power of 3, is it the same thing as put 1 inside it? So we have 1, open bracket, 1 plus 1 divided by 2, everything squared. Let's check if the two are the same. Wherever you see and just put 1. Put 1. This is starting from 1 already. So when k equals to 1 raised to the power of 3. Now when n equals to 1, put 1. N equals to 1, so this is 1, open bracket, 1 plus 1 divided by 2. 1 plus 1 is 2. 2 times 1, that's the 2. 2 divided by 2, that is 1. Meaning this one is also 1 square, which is 1. 1 raised to the power of 3 is 1. So meaning the left side equals to the right side when n equals to 1. Now the next thing to do, you assume that n equals to k. So that is, when you continue to sum this up to this, your result will be, this should be your Pn. That is, when you write this in expanded form, this is 1 raised to the power of 3 plus 2 raised to the power of 3 plus 3 raised to the power of 3 plus up to this term k raised to the power of 3. And our expected result is this, n plus 1 divided by 2 square. So when we replace n equals to k, it's just like you change this one to k, and that will just be 1 plus 2 raised to the power of 3 raised to the power of 3, everything equals to, change this to k now, so that's k plus 1 over 2, everything square. This is what you have. But this assumption, so we say this is true, you assume that this is true. So we say this, for n equals to k is true. That is, when you add everything up to k, you are going to get this result. Now, what do we need to do? We have to prove that whenever we replace n with k plus 1, the statement will still be true. And that is simply what you need to prove. How do we prove this? It's very simple. You need to first know your expected result. What is our expected result? Just go to the question. Where you have n, replace that n with k plus 1. That will be your expected result. So our expected result now, which is pk plus 1, this is our expected result. That will be, so now whenever we see n, we change it to k plus 1. K plus 1. Open bracket, k plus 1 plus 1. Everything divided by 2. Everything square. This is your n. K plus 1 is your n. N plus 1. So now we have this. So this should be our expected result. Now, but don't forget that this is the first term, this is the last term. For us to get this expected result, we need to extend this sequence up to our series up to k plus 1. So that meaning the next term after this one, will be after k, we have k plus 1, meaning we need to introduce plus k plus 1 raised to the power of 3. That will be the next term. And you know, once you add this k plus 1 to this term, it won't be equals to this again. So now once you add it to this side, you have to add it to the other side to k plus 1 raised to the power of 3. Now, when you add everything, then expected result should be this. Now, you can see now we balance the equation. We have this equals to this initially. We added k plus 1 raised to the power of 3 because after k is k plus 1. Now, balance it this side also. Now, what you just need to do now is to show that this, what you have here, equals to this one. And you know, this one too, if I simplify further, this is just k plus 1. K plus 1 plus 1 is 2, that is k plus 2. Everything over 2. Everything is k. So this is our expected result. So now let's show that this equals to this. And this is very simple. We only need the basic knowledge. Yes, we factorize and take the LCM. Now let's take the LCM from here. Our LCM is 2. So 2 here, that is just, okay, sorry. I'm sorry. This is square. So square will affect this. So LCM should be 4. So LCM is 4. You know, square will affect everything. So 2 square is 4. LCM is 4. Now, we have this here. So we have a k plus 1, everything square, plus, now, how many 1 goes in 4? 4 multiplied by that, that is 4 k plus 1 raised to the power of 3. Now, let's simplify this further again. K plus 1 raised to the power of 3, k plus 1 raised to the power of 2. We can just take out k plus 1 raised to the power of 2, k plus 1 raised to the power of 2. Now, once you take this, you are left with just k here. At the k plus 1 square. Oh, sorry, we are left with k square here. Because everything here is square. So we have k square plus. We took k plus 1 raised to the power of what? Raised to the power of 2 over k plus 1. So plus 4 k plus 1. And this is what we have. Everything divided by 4 again. Now we simplify further. Just open this bracket. So we have a k plus 1 square. K square. Open this bracket, that's plus k. 4k plus 4. Everything divided by what? By 4. Now factorize that one. When you factorize, you are going to have k plus 1 square, k plus 2 square. So now we have k plus 1 square, k plus 2 square, everything divided by 4. And I can rewrite this as a k plus 1, k plus 2. Since square is common to both, we can just take out the square. This is also square. So 2 square. So everything square. So that 2 square will give us 4. Square of this, square of this. And that is what we expected to prove. Now we've proved that by induction, this equals to this. Since basically that is what we do in induction, you generalize your proof. You are not expected to do it individually. If we continue to do it individually, you'll be getting our results. We get our results. So what you don't do it individually, you generalize it, and that is what induction is all about.